cos x plus sin x in brackets e to the power x. So I becomes cos x plus sin x e to the power x upon 2. So let's put the value of the integral e to the power x cos x plus sin x upon 2 plus p. This is our solution.
Yes, sir.
Right, easy. Just learn this formula. Y into integrating factor equals to integral of integrating factor into q.
Yes, sir.
Now, if the equation was in a different form, if the equation was in the second form, dx by dy plus, let's say, y times x is equals to log y. Is it a linear or not? Because it resembles dx by dy
dx by plus px is equal to q.
dx by dy plus px is equals to q. And p and q are really functions of y here. So p is simply y and q is log y. Let's find out the integrating factor. Integrating factor will be e to the power integral of p and now with respect to y instead of x. And how do we know कि ये किसके रिस्पेक्ट में होना चाहिए? जो डिफरेंशियल इक्वेशन के नीचे आ रहा है. डिफरेंशिएशन भी y के रेस्पेक्ट में हो रहा है तो इंटीग्रेटिंग फैक्टर में इंटीग्रेशन भी y के रेस्पेक्ट में. So e to the power integral, what is p here? Y. Integral of y dy. And what is the integral of y dy? Y square upon 2. Right?
Yes, sir.
So we get our integrating factor as e to the power y square upon 2. First step is over. The solution will be now, just need to swap x and y. The solution will be
Yes.
x into integrating factor is equals to integral of integrating factor times q dy plus c. So let's apply this in for this particular equation. The solution will be x into integrating factor is e to the power y square upon 2 is equal to e to the power y square upon 2 times q. What is q? Log y
Yes.
dy plus c. Now our job is to simply integrate this. Now how do we find the integral of this? E to the power y square upon 2 log y.
सर इसका भी उसी से ही हो जाएगा हाईलाइट.
Yes. So which function will be first and second?
Sir, log will be first and e is for y square upon 2 will be second.
Yes. So let's try. What will that be?
So log y into integral of e raised to power y square by 2.
But how do we find out integral of e to the power y square by 2?
So e raised to power y square by 2 upon 2y.
No. If it would have been e to the power 2y, then we could have applied that formula. E to the power 2y upon 2. Only for the linear forms, right? E to the power ax plus b forms we can do like that, but not for any function.
Yes, sir.
So e to the power y square by 2 ka integral, how do we find out? Let's think. If I take y square as t,
Yes.
so you will get 2y dy by dx equals to dt. No, I don't think so. इसका integral हम निकाल सकते हैं. This is a way complicated function. Right? So we should write the answer in this form only, because that
Yes,
is
sir.
not possible. So the question I made is a question is not evaluatable. Right? So integrating factor कभी y या x नहीं होगा, because it will make the integrating factor complicated. So we can simply write the answer is in this form. We can leave the answer in this form. Because we are not able to find the integral of e to the power y square or e to the power x square. There is no simple way to find the integral of this. So this is all about linear equations. Now let's do some more questions on this. Let's do example 22. The equation is dy by dx plus y cot x is equals to 2x plus x square cot x. Which form is it? Is it the first form or the second form?
Sir, cot x will be p.
Yes, this will be p and this will be q, so it is in the first form,
Yes, sir.
right? So what will be the integrating factor? E to the power
Sir, p dx.
p
Cot
dx,
x dx.
cot x dx. I'm sorry.
Yes.
So what will be the integral of cot x? Let's see if you remember the formulas.
Cot x.
Log sin x.
Yes.
Log sin x. And e to the power log sin x, isn't it simply sin x? Because
Yes.
log and exponential functions are inverse of each other. They get cancelled.
Yes, sir.
So the integrating factor is very simple, just sin x.
Yes, sir.
So our solution will be y into integrating factor. Let's write the formula. Y into integrating factor is equals to integrating factor times q dx plus c. And let's put the values of integrating factor. Y into sine x is equals to sine of integration sine x times q, and q is a little complicated function. 2x plus x square cot x plus c. Now our job is to just do this integration. It can be split into two integrals, 2 into x sine x plus x square into cos x plus c.
Yes, sir.
Because sin x will get cancelled, we'll just be left with cos x. Now these are two integration by part problems. X will be the first function, sin x will be the second function. Here, x square will be the first function, cos x will be the second function.
Yes, sir.
So what will be the integral of the first one?
Sir, x
Into
cos x
minus cos
x
x
cos x
minus
minus minus cos x को प्लस बन जाएगा सर.
minus cos x plus cos x. Very good. And let's do this one also. X square into sin x minus
Yes, sir. Minus 2x integral of 2x sin x.
integral of 2x sin x. And we have observed here that if we have not even integrated this integral
Yes.
will get cancelled, isn't it?
Yes, sir.
It's better to not even integrate that. Let's cancel out this. So the only thing that is left is x square sin x.
Sin x. Yes, sir.
The simple answer of this equation is y sin x is equals to x square sin x plus c.
Yes, sir.
The answer is correct. And we can even find out the particular solution by substituting the given values of x and y and finding c. Let's try 23. This is a word problem. Find the equation of a curve passing through the point 0, 1. If the slope of the tangent to the curve at any point, that means dy by dx, which is the slope, is equal to the sum of the x coordinate and the product of the y coordinate and the x coordinate.
Yes, sir.
ये equation बनेगी, right?
Yes.
Let's rearrange it and see if it is in the linear form or not. dy by dx plus something times x plus p times x is equals to q. इस फॉर्म में लेके आते हैं इसको.
Sir, p times y नहीं होएगा.
हाँ, p times y is equals to q. So what will that be? dy by dx minus x into y is equals to x. Is that correct?
Yes, sir.
We are again getting x square by 2. So we can integrate it. What will be the integrating factor? Minus integral of minus x dx. Because p here is minus x.
Yes, sir.
Right? If you integrate it, what will you get? E to the power minus
X square
by 2. But this particular integrating factor, if you merge it with q, it will become a simple integral.
Yes.
Our solution will be, what will be our solution? Y times integrating factor is equals to integral of integrating factor times Q plus C. That is our solution. So let's put the values. Y into e to the power minus x square by 2 is equal to integral of what? E to the power minus x square by 2 into Q. And what is Q here?
Sir, X.
X. Now this integral is integrable. The previous one was not. Why?
Yes, sir.
Why do you think so? Because if we substitute x square by 2 is equals to t,
X is equal to dt.
x is d, no, x dx is equals to d.
Yes, sir.
X dx becomes dt. So this integral will become e to the power minus t dt, isn't it? And e to the power minus
Yes.
t, the integral is minus e to the power minus
Yes, sir.
t, and replace the value of t. We will get minus e to the power minus x square by 2. And this is our answer. Y into e to the power minus x square by 2 is equals to this plus c. Now we need to find a specific curve, and the curve was passing through 0 and 1. So let's put 0 and 1. Get y is 1 into e to the power 0 is 1, e to the power 0 is 1, negative 1 plus c. So c is coming out to be 2. Therefore, the curve is y into e to the power minus x square over 2 is equal to minus e to the power minus x square over 2 plus 2. And we can even bring x square over 2 on the other side. The answer will be y is equals to minus 1 plus 2 times e to the power plus x square over. Let's check our answer. Yes, the answer is correct. Y is equal to minus 1 plus 2 e to the power minus x square over 2. Any doubts here?
No, sir.
What did we learn today? Linear differential equations. What is integrating factor?
Sir,
The two forms, form 1 and form 2. Right? And we also found out that integral of e to the power x square is not easily findable at your level. Okay?
yes, sir.
If there is any doubts, let me know. Let's see what, okay, the next is the exercise. So hopefully in the next class, we should be able to finish this exercise. And then we will come to the miscellaneous questions. Will you get time to do some homework?
Um. Oh, okay, sir. I'll do it.
I at least 5-6 problems from the beginning.
Okay, sir.
Right? These are based on this topic only.
Yes, sir.
first 5 problems and then we will do the later ones in the class.
Okay, sir.
Okay, bye.
Thank you, sir.
Thank you.